sort of take JavaScript a little bit back to basics. I don't know if anyone's seen this quote. It's by Brendan Eich. Basically, he worked for Netscape in 1995. The internet was new. Client-side scripting was like this cool thing that we thought about doing. And he was trying to cram JavaScript into a release of Netscape. You had basically 10 days to make something. And because Java was like the new hotness of 1995, it had to look like Java, right? What we ended up with is something like JavaScript to Java is a bit like ham is to hamster. It is not the same thing at all. But we call it JavaScript because JavaScript's cool and blah, blah, blah. Some people say that he was a bit high at the time. Obviously, we all think that JavaScript's really awesome. There's a whole book about all the good things in JavaScript. I'm assuming that half the room at least have read it. The other half probably should. So if you stick to what's in this book, and everybody that you work with stick to what's in that book, and you're all treating JavaScript nicely, you might not have come across any of the things I'm going to talk about. But if you're like me, and you get to see a lot of legacy code, and you get to sort of work with people who make mistakes, then you probably will see some of the things that I'm going to talk about. So basic software development, right? This is all we do all day, every day. We check some conditions, and then we do something based on whether or not that condition is met or not met, right? Basically, all software boils down to that. And so it's really important, whether that thing is true or not. It's really important to know how the things inside those parentheses evaluate. Or, no parentheses if you're working in another language. But you've got to work out what's true. And so JavaScript's got, a couple of interesting things that evaluates to true. So obviously, Boolean, a true Boolean is true. All right, the string false is also true. An empty array is also true. And any number is also true. All right? This is basically JavaScript's loosely typed. And that means that what sort of thing a variable is, like if it's a string or a number or whatever it is, that's only determined once you start using it. All right? So it's just like this vague concept, and then you assign 5, and it goes, cool, it's a number. Right? So the other part of that is that JavaScript got something called type coercion. Now, I think a few people have mentioned type coercion earlier today. Type coercion is something you need to understand if you're working in JavaScript. I don't really care if you work in like CoffeeScript or any one of the 1 million languages that compile down to JavaScript. You're still a JavaScript developer, so you need to understand JavaScript. You need to know what JavaScript does. All right? So type coercion basically means that depending on the context that the variable is being used in, if JavaScript isn't entirely sure, it's going to try and guess. All right? So it's going to go like, I know you can't really, it's a string, and that's not really a Boolean, but I'm kind of sort of going to guess that because it's not actually an empty string, you probably mean true. All right, so all that guesswork that JavaScript does, that's basically what type coercion does. And so there's all these things that then are false, right? Obviously, false is false, right? Not a number, it's also false, even though it's an object. Negative 0 and 0 are both false. Null is false, undefined is also false, and an empty string is also false. All right? So any of these things, JavaScript will go, well, it's not a Boolean, but I'm just going to kind of try and work out what you probably meant. All right? JavaScript's not hugely good at working out what you probably meant, so you probably want to be a little bit more specific. All right? Who's done that? Hands up. Who has tried to add 2 things, and you thought it was 2 numbers, and then 1 + 2 turns to 12? All right, everybody who's got their hands up are honest. Everybody else is lying. All right, if you haven't done this in JavaScript, I don't think that you've developed any JavaScript. Right? Now, when you do this, remember that you still have operator precedence, so that you get the sort of famous 1 + 2 + 3 becomes 33 instead of, you might think it was 1, 2, 3. right? Because it gets evaluated from, I'm going to get my left to rights confused no matter what I say, but you know which way it gets evaluated in, right? And so we get this sort of thing as well, right? We go, is 5 equal to the string 5? And JavaScript goes, sure, yeah, that sounds good, right? And you get this sort of thing. True is the same as 1, and false is the same as 0. Sure, yeah. And it's kind of like this, right? So JavaScript kind of like sits on a dog and hopes it's going to turn into a chicken at some point. So basically the morale of this is like, JavaScript is not Java, all right? Double equals, I mean, everybody in this room knows you should never, ever use double equals, right? Except, no. I've seen lots of people use it over, yesterday and also today, so it's not something that everybody just knows. But JavaScript has something we call the are you sure operator, right? And that's the solution to this problem, where x is undefined and y is null, and you ask, hey, is x and y the same? And JavaScript goes, yeah, close enough, right? And then you go, are you sure? And JavaScript goes, well, they're not really the same type. So yeah, no, they're probably not the same, right? Now, null and undefined, you might want to argue that they really do need both things anyway. But there's a few other things that, leads to a couple of sort of interesting outcomes, right? So x is a new array. Array is typically an object, right? It's empty, and so you ask Java, is the empty array the same as false? And JavaScript goes, yep, cool, totally the same. And you go, are you really, really, really sure? Nah, that kind of, they are different objects after all, so yeah, I'm just going to go with false this time, right? 1 is actually false as well. 1 is not, in fact, actually true, even though JavaScript might think so on the first try. It is, different types. So these are all kind of like trivial and small examples, but you have this other kind of interesting thing, right? Where you go, A is a new array. You instantiate it with like a couple of different things, an empty string, a null object, an undefined object, and you go, hey, JavaScript, is that the same as a string with 2 commas in it? And JavaScript goes, yeah, totally. Right? Because what JavaScript is doing here is type coercion, right? It doesn't really know what you mean, but it's going to try and work it out. And so it goes, well, yeah, so you're trying to compare A to a string, so I need to make A into a string. Okay, so I'm going to run a 2-string on the array. Oh, but not all the objects in the array are strings, so I'm going to try and convert them. Right, so that's already a string, the first thing, and then null. So, okay, that'd be false, and then we turn it into an empty string because we want to make false into a string. And you get this sort of weird shit happening where JavaScript goes, yeah, totally, it's just 2 commas, right? And you go, are you sure? And you go, hell no, they're totally different things. One's a string and one's an array. You can't compare them, all right? So you dig deeper into this, and you can put up heaps of examples, and there's some interesting behavior going on, and this is sort of one of my favorite sort of, type coercion in JavaScript will make life hard for you, so don't rely on it. Right? So we have this WTF, which is a new array, and you ask, is it equal to itself? And JavaScript, yeah, obviously, this object is exactly this object, so yeah, they're totally the same, right? And then you ask, is it equal to not itself? What do you think you get? Crickets. Yeah, totally. And you go, really, JavaScript? How did you get there? Right? What? How do you do that? All right. So I'm going to try and explain it, and I'm actually going to look at my presenter notes because I wrote it down and it still doesn't entirely make sense for me, right? But to explain what's going on here, so the right side basically converts the array to a Boolean, right? And that's true. And then it flips it, right? So the bang flips it false. And then the double equal operator, because the types are different, converts the left side to a primitive value, right? Calling value off. And that primitive value is 0, right? So that becomes false as well. And so they're equal. So it becomes, not itself. It's got a bit of an identity crisis going there. It's like, what? So basically, right, WTF is an array. Not itself is false. Is that equal to true? And then, yeah, you get this. So, moral of the story is ask, are you really, really sure? Because that behavior is just kind of strange, right? You can get these like really, really, really weird bugs coming out of this sort of stuff. And you have like on one side there's like double equals. You save space. You save bytes because you can like take out one byte with the equal. Or you have triple equals will actually make you sure. I was talking to another presenter yesterday, and I pointed out to him that he'd used double equals as a presentation, and he's like, yeah, but I know what it does, so I can do that, right? And okay, for a bit of demo code, maybe you can do that, but you're demoing to what? Like how many people in this room? 300? Right? You're showing bad behavior to 300 people. That's probably not cool. And if you're writing actual real production code, all right, you're basically making the assumption that anyone who is ever going to touch that code knows exactly how the double equal works and wants that behavior. All right? Which is why you should basically only use double equals when you really want that behavior, when you want implicit type coercion. Otherwise, just don't. Just do it explicitly and use triple equals. Because, about 30% of all your JavaScript bugs ever are going to come from type coercion. Oh, shit. OK. So let's leave type coercion alone for a little bit of a little moment and talk about some other sort of crazy things I've seen in the wild. Arguments. So everybody knows the arguments object? At least like 3 people nodded. So basically, the arguments object is a special, very special object, where any function that you have, even if it has no parameters, will have an arguments object, and that arguments object will contain a list of all the arguments that was passed into that function, right? So if we call this function Bob with hello world, or return, the second element of what, kind of looks like an array, it'll return world. And we're like, oh, cool, great, it's an array, I can use this is exciting, I can pass in, all these arguments and do stuff with them and stuff, and I'm just gonna like try it out briefly, and just gonna loop through them. All right. So you pass in all these like hello world Bob things, and out comes 0. If you're trying to list all those arguments in a for loop, you get 0. So I said we're going to leave type coercion alone for a while. That was a lie. This is type coercion, right? Causing this, right? Because arguments is not actually an array. It's some other sort of special object. And you might think that it's an array because it looks like it's indexed, when it turns out, in fact, it isn't actually indexed. And so what you get here is that the for loop is expecting some sort of like indexed thing that it can, get the keys out of. And arguments is not that. And so JavaScript goes, ooh, how to solve this? All right, I know. I will make a 0-length array. No, sorry, 1-length array. And the arguments will be the only object in that array. And then as the key, I'll return the index. Yay, problem solved. Like, not really. So just beware that the arguments is not actually an array, even though it sort of behaves like it. Some more interesting fun. So I'm guessing everybody at some point has gotten some user input, and they're trying to pass it in their JavaScript, right? It's kind of what JavaScript does, like interaction in the browser kind of thing. And so, you pass them things, and you worked out that you shouldn't use a double equals, use a triple equals. Turns out that you have a number and a string now. Well, okay, so there's this passing thing. I can pass the string and turn it into a number. Really cool. Okay, so you get some input. You get 7. You get 0, 7. That all works. 0, 0, 7. Double agents. Pass 8, and then you pass 0, 8. You get 0. And you go, what? Is it because it starts with 0? Right? And then you pass like 0, 18, and you get 1. And you go, that's not what I meant. Right? And you pass another integer, like, what's going on here? What the hell? Like, is JavaScript broken? Right? Now, the answer actually lies in the name, right? It passes an integer. There's nothing in that name that says it's passing a decimal integer. That would just be you making assumptions, all right? JavaScript is like, numbers that start with 0, I know what they are. They're octals. Yeah. You probably meant base 8, because base 8 is totally like normal user input. We all do that all the time, all right? So you get sort of like funky behavior like that, where you've written some code, you pass something, then you create a new string, you put it out, and you're like, wait, I don't think that should be 18 actually. Is it like an off by 2 error? Is that a thing? I've heard of off by 1, but So you actually got to do this, right? If you're going to use this function, you actually got to pass in a second parameter that was called a radix, which basically says which number system you're working in. And JavaScript will happily take any number between 2 and 36. Now, if you've ever actually written an application depending on this behavior, it's actually going to get dropped in ECMAScript 5, so whenever that hits the world, all your applications that depending on implicit octal integer passing will break, all like one of them. Passing floats doesn't have this problem because the assumption is that only decimal numbers will have floating points. That's fair enough. Probably non-decimal numbers with floating points is a bit of a sort of domain of maths geeks, and they probably wouldn't use JavaScript anyway. And remember that JavaScript is really friendly and helpful, and will assume that any input that you have given is correct until proven otherwise. So if you give it a string and it just happens to start with a number, that's cool. We're just going to kind of go, yeah, 2, close enough. Excellent. All right. So hiding from a monster a little bit. It's sort of kind of hard to get away from all the bad things, especially when things just don't make sense anymore. Infinity is a great example of this. All right. So you got this function. Math function, brilliant function, right? You just pass in a bunch of numbers, any number of arguments, and it'll return the highest number. All right? Now, I said any number of arguments, including 0. All right? And math.min is sort of the inverse, right? You can pass in any number of arguments, and it'll find the smallest one. So what's wrong with that picture? So the greatest number in the JavaScript universe is apparently negative infinity. And the greatest number in, the smallest number in the JavaScript universe is apparently infinity. And you might think that that was the other way around. All right, so infinity is actually a real number, and you can compare other numbers to it. It's actually a meaningful number in JavaScript. You can do funky stuff like that. And obviously, you're using it wrong, right? It's not how that function was supposed to be used, right? But here's the thing. If you have a function called math.min, you might kind of, without having read the first book or the second book, or really read any book at all, but you're just kind of trying to hack some JavaScript into your web page, which is what happens a lot of the time, and you might think that that function would return, a large or a small number, and you'd kind of, you'd use it like this, right? That's actually a real live example I have seen in an atrocious piece of JavaScript at some point. Brendan Ike actually managed to explain it all in a single tweet, basically saying it's not weird. You want max to use negative infinity as seed and min to use positive infinity as seed. Seed is the initial comparand. So basically, the comparand is the smallest and the biggest number that it's safe to compare other numbers to. When it doesn't have any other numbers to compare to the initial comparand, it just returns the initial comparand. So it might make perfect sense, like in a sort of strict logic kind of way, but you know, as far as expected behavior goes, probably not it. All right, so I'm running a bit short on time. I just want to do something interesting very quickly. Number.min value, which you might want to use instead of math.min, is actually bigger than 0. It is the smallest number that you could possibly get while still being bigger than 0, which again makes perfect sense, except it's probably not actually what you expected. Our favorite little sort of JavaScript subject is we've learned all about this triple equals operator, and so we're like, cool, okay, I'm going to write some real stuff now. 0.1 plus 0.2 equals 0.3, right? No! Bow bow. So binary representation of floating point numbers is a problem. It's like a well-known computing problem. It's just one that JavaScript more or less completely leaves up to you to deal with. So if you need to do comparisons of floating point numbers, basically here's your problem now, and you have to write either algorithms that check are these numbers in a sort of close enough range, because basically what you get is this, right? So the binary representation of 0.1 is actually 0.00 lots of zeros 1, and the binary representation of 0.1 plus 0.2 is, well, that. And so you can check if it's accurate to within a range, or you can start sort of boxing numbers into floats into integers and then converting them back, or you can just like use another language for important floating point calculations. So I'm not sure if that was new to most of you guys, but I'm hoping that it was either a trip down memory lane for some of us. I have personally done at least half of those mistakes and seen the other half live. And for those who are sitting there and going like, I've got code like that, go fix it. And then there's like the lucky few who goes, I'll never do that. And good luck to you. Thank you.